Okay guys, so this is going to be our last week of assignments dealing with exponential functions, and then we'll move on to something new next week. So, as before, I'd like for you to copy these down your spiral and copy them down and leave plenty of space in between so we can work through these quickly on the video. So, we used this formula last week. A is equal to P times 1 plus R to the T. Okay? So that would just be like a basic annual annuity problem where we're doing compounded interest. Now, when we're talking about exponential rates, they can be positive or negative. So if it's increasing, it's going to be positive. If it's going to be decreasing, it's going to be negative. So we're not going to be compounding this in most of these problems. So you don't have an n in this, and you don't have an n up here. But it's pretty much the same principle. Your A is your final amount. Your P is going to be your principal amount. Your R is your rate of growth. And your T is going to be your time in years or weeks, just depending on what the rate is. Okay? So first example, it says the population of Greensville is increasing at a rate of 5.6% per year. If the population today is 8,000, what will it be 10 years from now? Okay, so we're going to use A is equal to, your principal amount is 8,000. It's growing at a rate of 5.6% per year. So we convert that to a decimal. So when we convert that to a decimal, we move it 2 decimal places. See, I moved it 2 decimal places to the left. And we're going 10 years from now. Okay? So, the way I'm going to put this in the calculator is I'm going to do 1 plus 0.056, okay? And I'm going to hit enter. I'm going to raise that to the 10th power using the caret. And then I'm going to multiply by 8,000. Remember, order of operations. Please excuse my dear Sally, you got to do the exponents first in the parentheses. Okay? So I get 13,795.24. Now, in some of these questions, they say round to the nearest whole person. I mean, can't have a half of a person, so or a quarter of a person in this case. So we're just going to leave it like that. Okay, if you have an investment account, you have an invest account that is increasing at a rate of 2% per year, per month. Here, I need to correct this error. Okay, that is increasing at a rate of 2% per month. If you have invested $700 today, how much will you have 2 years from now? When will you have $10,000? Okay, so this is a two-part question. So we're going to use A is equal to P times 1 plus R to the T. Okay, so I want to know how much I'm going to have in my account 2 years from now. So today I have $700. My growth rate is 2% per month. And my time period is 2 years from now. Now, so how many months in a year? Well, there's 12, okay? So 2 years from now, it's going to be 24 months, okay? So you got to pay attention to your time units. So 1.02 to the 24th power times 700. And then at the end of 2 years, I will have $1,125.91. Okay. Now it says, when will you have $10,000 in the account? So we're going to use the same formula. But this case, I'm going to be solving for T, okay? So I know when I have $10,000 in the account, I start with 700. My rate is still 2%, and I'm going to solve for T. Now, so what I noticed on some of your homeworks is you're not doing this right. You have to divide the 700 first. You have to isolate the exponential, okay? So we're going to do 10,000 divided by 700 first. So 10,000 divided by 700 gives you 14.2857. Is equal to 1.02 to the t power. Now, anytime we're looking for something in the exponent, we're going to have to natural log both sides. So natural log of 14.2857 is equal to t natural log of 1.02. And then we're going to divide both sides by natural log of 1.02. So natural log of that divided by natural log of 1.02. And I get 134.29 months. Okay, and if it asks for years, you would divide that by 12. It'll take about 11.19 years, okay? Next example, it says, suppose that you take 800 milligrams of aspirin at 1 p.m. 5 hours later, you have 100 milligrams of aspirin left in your bloodstream. What is the rate of decrease of the aspirin in your bloodstream? So A is equal to P times 1 plus R to the T. Now, since it's decreasing, the amount is decreasing, we're going to make this a negative, okay? So, the final amount is 100 milligrams. I start with 800 milligrams. And it's 5 hours later, so I'm going to put a 5 up here in the exponent. So the whole goal is to solve for R. So, just like we did before, we're trying to solve for something in an exponent. So, we're going to divide both sides by 800. So 100 divided by 800 is 1/8. Okay, so this is a little tricky. We're not going to natural log both sides because we're not looking for something in the exponent. We're looking for something that's in the base. So how do I get rid of the fifth power? Well, I'm going to fifth root. Okay. And so I'm going to go ahead and put that in a calculator. 1/8. Okay, I'm going to hit enter. Now, if I'm going fifth root, I'm going to raise it to the 1/5 power, like that. So you get 0.6598. Okay, now solving this equation right here, we're going to add our r to this side and divide, and then subtract it to the other side, the 0.6598, subtract it to the other side. So r comes out to be 1 minus 0.6598, and you get 0.3402. Okay, so what this means is you're decreasing the amount of aspirin in your system every hour by 34.02%. Okay, so you can write it as a percentage, or you can leave it as a decimal. Okay, a virus grows at a rate of 2.8% every day. Currently, there are 20,800 deaths from the virus. How many deaths can you predict at the end of the week, which is a 7-day period, assuming an exponential growth model? So A is equal to P times 1 plus R to the T. Okay, so we're looking for the final amount of deaths. You have 20,800 currently, and it's growing at 2.8%. So 1 plus 0.028. Okay, so to get the 2.8%, I moved the decimal 2 places to the left. And I want to know at the end of a 7-day period. Okay, so I'm going to raise this to the 7th power. Okay, so we're going to do this portion first, the 1 plus 0.028, raise it to the 7th power, and then we're going to multiply that by 20,800. So by the end of this week, we're probably going to have somewhere close to 25,235.6 469 deaths. Okay, and I use this kind of based on a conservative approach to the death rate of what's going on right now with coronavirus. I think it was Saturday or Friday night, there was 20,800 whenever I wrote this. So the death rate's about 3 to 4% right now. Just kind of depends on the day. So if we're doing worst case scenario, we can probably expect at least this amount dead by the end of this week. So hopefully this helped you out. And if you have any questions, feel free to reach out. Thanks and have a good day.